quantum science has been developed over the last 20 or 30 years, is very mature at this point. Now, it's still important, and it will be extremely important that we continue to study and advance the fundamental science around quantum information. But at the same time, if we want to realize these practical applications, we need to bring up the engineering, the quantum engineering, to the same level. And at MIT, we want to be synonymous with quantum engineering, not just quantum science. MIT is a special place. There are very few places in the world, if any, where you have many of these leaders in quantum information science, the quantum science, the development of algorithms, the experimental efforts, and also it's a fantastic engineering school. We have some of the best engineers in the world, some of the best computer scientists, computer architects, quantum chemistry, people who do classical simulations of quantum chemistry, and all of these people exist here now. And what we can do is, through the Center for Quantum Engineering, pivot into this new direction, which is quantum science and quantum engineering, and it's all happening right here. So another key differentiator and an advantage here at MIT is that MIT has always been focused on mens et manus, so both science and engineering. And it's not enough for us to just do the best science, but we want to make sure that that science gets out into the real world, into industry, so that it benefits humankind. And another differentiator is that it's not just the MIT campus and the academic environment, but we also have Lincoln Laboratory, which is a top US government lab. And these two together are an unbeatable combination, because the places that are going to succeed in the future are the ones who have the infrastructure, both the physical infrastructure, but also the personnel, the people. It's the people that make the difference. All of this infrastructure together in one place to be successful. So a lot of companies or people from companies will ask me, why should I get involved now? Maybe I should wait a few years and see how things are going. And I understand that. The one response I usually give is that if we think back to, the development of classical electronic computing in the 20th century, how did that unfold? And, it may not be a surprise that many of those top companies worldwide are located here in the US, because those were the companies who got in there first, or they purchased the companies that got in there first. And they've been in it from the very beginning, maybe even before it was clear where the technology was going. We didn't know about cell phones in the 1950s. So a good parallel here may be the semiconductor industry. And the first transistor was invented in 1947. It was just a discrete single transistor. And about 10 years later, we had the first fully transistor-based computer built at MIT Lincoln Laboratory. And similarly, many of the quantum algorithms that we'll use on a future quantum computer were developed here at MIT. And now what we're seeing is the hardware starting to come in. Some of the best fabrication of superconducting qubits today is being done here at MIT. And the cold classical electronics, which we'll use to control a future quantum computer, those technologies are being developed here at MIT. Trapped ions used to be made in these large three-dimensional cavities, but of course, to truly be scalable, you need to make them on a chip. And 3D integrated trapped ion quantum computers are being made here at MIT. And 3D integration of superconducting circuits, nobody does it better than here at MIT. And so this represents the types of technologies that today are just starting to be developed, but are going to push forward the technology in 10 to 20 years.